Okay, let me continue our discussion. So, for modified factor C1 due to non-uniform bending moment. So, for the bending moment diagram that is equal or uniform along the beam, the value of C1 is equal to 1.0. Then for the triangle shape, full triangle shape like this, C1 is equal to 1.35. But normally, for this case, we introduce lateral support at the point where the point load is applied on the beam. So basically like this. So we have lateral support at this point. So the bending moment diagram is actually splitted into three area. Here C1 is equal to, for the half triangle, C1 is equal to 1.77. So same as this one, C1 is equal to 1.77. But for the interior diagram of bending moment, so we have a trapezium shape M1 and M2. And then the ratio between these two bending moment is the smallest bending moment M1 over M2. The value of C1 is based on this, determined by the value of ratio of bending moment. Later we discuss in detail on the contribution of the ratio of bending moment to the value of C1. There are several expressions proposed by the researchers on how to calculate the C1 using the value of C. But in the book, you can refer page 212, table 5.12, page 212. Travel record. Okay. There's C2 factors. It will lengthen the expression of MCR. So when the bending moment is introduced here, So we have uh, long expression here, longer expression here, plus C2 ZG squared and then minus C2 ZG. And this is the longer the expression. Stabilizing, and then C1 here. Okay, so from this expression we can determine that the longer the unrestrained segment, unrestrained segment, the lower the value of MCR, the elastic critical buckling strength, and also the value of C1 modifying the value of the MCR. I mean, it can be can be increasing the value of MCR, or can be reducing the value of MCR. Okay. In the Euro code, clause 6.3.2.3 of Euro code 3 part 1.1 determine the process of calculating the reduce factors. So basically you can find the design resistant to bending and axial compression due to bending or buckling design resistant. Is in the clause 6.3.2 uniform member in bending. So the MED design requirement, the MED over MBRD should less than equal to 1.0, and then the value of the FMBRD, that's the buckling design resistant to bending moment, is calculated by introducing the reduce factor CLT times Fy modulus plastic about Y over gamma M2. N1, sorry. So this one is a reduction factor, sorry. So basically in the buckling failure, when we reflect it on a stress and strain diagram, so the buckling failure is never reach the yield strength. When it is the yield strength Fy, so this is the failure. So that's why we introduce the reduction factor CLT to estimate the design resistance or buckling design resistance to bending moment. So to calculate the reduction factors and then the other factors that affecting the strength, the buckling design resistance strength to bending moment, is basically by the one is the CLT, and then the imperfection factor, and then the slenderness factor, and then the buckling factors. Since these parameters affecting the design resistance of a beam, laterally unrestrained beam, to buckling, to bending moment. So this one is call it imperfection factor. And then is slenderness, and it's a buckling factor. Buckling factor. All these factors can be found in clause 6.3.2.3 of Eurocode 3 Part 11. The step number 1 is determine the L unrestrained segment length. Unrestrained segment or length of unrestrained segment. So the different structural arrangement will give you different length of unrestrained segment. Example, a beam that simply supported at both ends. So the unrestrained segment is here, the whole span. When a beam it has secondary beam here, so then unrestrained segment will be 2 here, L1, L2. This one is secondary beam, at this point, attached at this point, provide lateral support. So in this case, we have two unrestrained segment, unrestrained segment 1 and unrestrained segment 2. If the size of the beam is equal along the span, so we need to consider only this segment, because if we return back to the expression, this expression, the longer or the bigger the value of L that reflect to the longer unrestrained segment, so the smaller the value of MCR.